It's a beautiful day to write some code. Let's get right into it with Leet code number 643. Maximum average subarray 1. You are given an integer array nums consisting of n elements and an integer k. Find a continuous subarray whose length is equal to k that has the maximum average value and return this value. Any answer with a calculation error less than 10 to the minus 5 will be accepted. So there's a bunch of different ways to solve this problem. We're just going to go about it intuitively. Spoiler alert, we will run into a time constraint with the intuitive approach. So we'll just address that when we get there. So what is a continuous subarray whose length is equal to k? So we're basically given this list of numbers, and we say we want to find a continuous subarray, so a list within this list whose length is equal to this number k that we're given. And then we want to find, looking at all of those lists within this list whose length is of k, what is the maximum average value of those that we can find? So the intuitive approach is we know how to walk down this list and look at things one at a time. Let's start there. So we want to find a list within this list that is k things long. So we could walk down this list, look at one thing. Do we have k things? Think of it as walking down and putting these things into a bucket. When we have k things in this bucket, then we're going to find the average and set it to see if it's the max average that we found. If it is, set it. And if not, just continue. So we're going to walk down. We have options as we walk down. We could experience this new item and we could say, do we have k things in our bucket? No. If not, then add it to the bucket. Okay, and then if we experience an item, say k in this case is 2, so say we experience this one, do we have k things in this bucket? We do. Okay, so now let's average and see if that's our answer, and set it as the average so far. If we have experienced a new item and we have k things in this bucket, instead of adding it directly to the bucket, we're going to put the oldest thing down first and then add that in. And then we're going to make our average calculation and add it to our running, check it against our running max. And we're going to do this all the way until the end of the array. And then by the time we get to the end, we should know what the maximum average is of all the lists within this list that were of length k. All right, hopping into the code here. So we're going to walk down intuitively and we're going to see a few things that we run into, and we're going to see the bugs that they cause, and we're going to go from there. So the first thing we're going to start as, we know how to walk down everything in this list. So we're going to say for num in nums. And then what do we want to do upon looking at every item in this list? Well, the first thing we're going to want to do is we're going to want to, keep track of our bucket. So we'll say update bucket. And then the next thing we're going to want to do is we're going to want to keep track of what our answer is here. So the answer that we're looking at is we're saying we want to go down on this list for all the buckets that we could find of k things in a row. What is the maximum averaged value of that? So after updating our bucket, we are going to then make our new maximum average calculation. So I'll have max average calculation. So what are we going to use as a bucket? Well, we want to be able to put things down from the oldest thing and then pick up the newest thing. So the data structure we're going to use for that is a queue. So we're going to say from collections import dq. And then we're going to make a bucket equal to a new dque. And then what are we trying to even do here? We're trying to have this max average of our bucket. And we'll just set this equal to none right now because we don't know what it is. This list can have negative numbers in it too, so we can't just start it at 0. So, okay, now for looking at every number, what are we going to do when we update this bucket? Well, at first we're not going to have k things in this bucket. So if we have less than k things, just add it to the bucket, don't do anything else. So if the length of our bucket is less than k things, then what we're going to do is we're going to say bucket dot append num. We're just going to put it in there. Otherwise, say elif the length of our bucket is equal to k things. Well, then we have some stuff to do. So then we have to put down the oldest thing and add the newest thing, and our bucket will be up to date. So then we could say bucket dot pop left, and this is going to put down our oldest thing, and then we could say bucket dot append, and this is going to add the newest thing. So up to this point, we should know every time we encounter a new thing, our bucket's up to date considering this new thing. So then what do? Well, if we have k things in our bucket, we want to make an average calculation and check that against our current average. So we'll say if the length of our bucket is equal to k things, then we're going to make this average calculation and check it against our answer, the maximum average. So let's calculate the average. So we'll say the total of our bucket is going to be equal to sum of bucket. This just sums up. If we have a list of numbers, it returns the sum of all the numbers in that list. And then we're going to say our new average is going to be equal to the total of this bucket divided by k things, since we know there's k things in that bucket. And then we're going to set this max average. So what are we going to set it to? Well, we're going to say this max average is going to be equal to whatever it is now, whatever's bigger between what it is now and our new bucket average. So the biggest of the two is what we're going to set the max to. All right, let's run this and see what we get. None is not a valid expected return type double. So the first error we get is that we forgot to return our max. So let's return max average at the end of this entire function after we look at everything in the list of nums one time. So, and we also forgot to add max here. We're going to be setting our max average to the maximum of our current max average and whatever new average we're experiencing here. So let's go ahead and run this and see what we get. Then I notice this keeps on happening. It keeps on getting rounded down, so floor division numbers, even though when we calculate our average here, we get total divided by k. So to fix this, I just manually converted k to a float, since this is going to be dividing two integers. In Python, it should return a float, but for some reason in this Leet code editor, it is returning a floor division integer. So then, as we can see, we get working answers here. So this is the intuitive approach, and this works. But when we go to submit this, what do we see? When we submit this, we see that our time limit has been exceeded. So why is our time limit exceeding, and why is this not going as fast as we'd like? Well, we could see this in our average calculation here. So every time for everything that we look at, every time we make an average calculation, which sums our bucket every time. This takes time right here to iterate through whatever our bucket is. This k could be huge. We could have a huge bucket. So, but as we can see, when we're updating our bucket, we're putting one thing down and picking one thing up. We could do this same thing to our average. So we can now keep a running average instead of having to make this calculation every time. So let's make this improvement and see what we get. So now we're going to want to keep track of a window average. And we're going to set this equal to none at first. And then when do we update this window average? Well, every time. Let's actually set this, start it at 0, and as we update our bucket, we'll update our window average. So we'll start it at 0. Every time we add something to this bucket, well, let's go ahead and add it to the window average too. So we're gonna set this window average equal to whatever it is plus our num. And then when we have k things, what do? Well, whenever we take something out of the bucket, let's take it out of the window average. So we'll set our window average equal to whatever the window average is. And then now we're going to subtract, we'll call this out. So this is going to be the actual number that's popped out of that's coming out of our bucket. And we'll subtract that from our window average. So we'll take window average equal to window average minus out. And then we'll also do the same thing here. Whenever we add it, the new one to the bucket, we'll add it to the window average. So now our window, and this is not an average, actually this is the total. So this is a total in our window. So now when we make our average calculation, instead of having the sum, this total is going to be we could rename this to window total. And then we could update this wherever we called it window average, since this is actually the total. And then instead of calculating this total, we could just toss it right out and use our window total here in our average calculation. So let's go ahead and run this. All right, only 268 milliseconds. Well, that is all for today. If you found this video helpful, feel free to check out the channel for more. Thank you. Have a good day.